All right, good afternoon, good evening. I'd like to welcome you to the Vertical Flight Society Virtual Tech Talk with Ms. Susan Gorton from the NASA Revolutionary Vertical Lift Technology Center. I'd like to thank our members from the sister chapter out in Philadelphia for supporting this event. My name is Tim Wheeler. I'm the program director for the Arizona chapter out here in the West. So we'll go through a couple quick items here, look at some of our chapter activities out here in Arizona, look at some of the STEM stuff we've done, and then we'll get right into the tech talk since that's why you guys are all here. Out here in Arizona, some of the accomplishments we have is we had a successful eVTOL, AVTOL conference back at the end of January. It was an outstanding event. You've probably seen it in Vertiflight magazine. And if you were able to be there or support it, it was an excellent event. So big thanks to everyone who came out and helped out with that. We've also restarted our dinner meetings, and the first two that we've had, the first one was back in September. We had Mr. Dave Minke from Honeywell Aerospace, who's the chief engineer for power generation, came out and gave us a talk. And then in November, we had Mr. Shane Openshaw come out, who's the vice president of Boeing tilt rotor programs. And so he gave a good talk on the V-22 program. So we've got some exciting things there with dinner meetings, and we're looking forward to the ones that are coming up here in the future. Some upcoming events we have, Embry-Riddle up in Prescott. They have their senior design presentations coming up at the end of the month. And so that's something we like to go up and support with, sit on the panel discussions and just interact with the students and see what all fun events and projects they have going on. We also have, we do some joint meetings and events out here as well with the Army Aviation Association of America and the Army Aviation Heritage Foundation. So we're having our joint picnic on Saturday, April 29th over here at Falcon Field. So that should be a good event to kind of mix around and mingle with other people from other organizations. And then our next dinner meeting is currently templated to be mid-late May timeframe. And we're still working on locking down a speaker for that. You can also expect that that'll be at the Sheraton like our previous dinner meetings as well. So some of the STEM events we have, we've done the Innovation Summit, and we take the little handheld helicopter props out for the kids. They really enjoy that. And we also have a new mobile simulator that we take around. It's PC based, and you can see it there on the left. Give the kids a chance to fly around in a helicopter and really learn how the helicopter controls work. So it's a lot of fun to see that. And we also partner and do a lot of events with the East Valley Institute of Technology, EVIT, over here on the east side of Phoenix. So some upcoming events in May, we've got a scheduled event with U of A Mesa program, and so that should be a good event. And then we just have, STEM nights and simulator demonstrations, so we're always looking for work to do with that. For anyone who is interested in seeing what we do, what we're doing, what we have on our calendar, if you'd like to help volunteer and come out and support some of these events, please go to the vfsaz.org site, and you'll see all our scheduled events on there. So, and with that, it is my pleasure to introduce Ms. Susan Gorton. Susan got her Bachelor of Science in Aerospace Engineering from the University of Illinois with a Master of Science in Aeronautics from George Washington University. Starting her career, did 15 years as a research for Army's Aeroflight Dynamics Directorate, which is now the Technology Development Directorate. From there, she moved over to NASA, where she's been for the last 24 years, and the last 17 of that has been as the project lead for revolutionary vertical flight technology. She's authored or co-authored over 85 publications and received numerous awards, 3-time recipient of NASA's Outstanding Leadership Medal, NASA's Exceptional Achievement Medal, the Army Civilian Service Medal, Research and Development Award, University of Illinois Aerospace Engineering Outstanding Alumni Award, VFS Augusta Westland International Fellowship Award, and her team received the Collier Trophy for the Ingenuity Mars helicopter, She is an honorary fellow of the Vertical Flight Society, an associate fellow of AIAA, and also holds an FAA private pilot's license in helicopters. So with that, I will turn it over to Miss Susan Gorton.
Thanks, Tim. So we should be seeing some slides.
We do.
All right. Well, we are ready then. All right. Well, thank you very much for having me. It's great to come out and talk to folks in the virtual world. Really makes that even more possible. So as Tim said, I'm Susan Gorton. The project I manage is Revolutionary Vertical Lift Technology. But today I'm going to cover a little wider scope than that and talk about the NASA Aeronautics Vision for Transforming Aviation. And then I will focus more on the vertical lift aspects of that as we go through the presentation. One of the first things I want to start off with is, why is aeronautics the first A in NASA? A lot of people think that NASA is the space organization, but really the NASA started out as the National Advisory Committee for Aeronautics in 1915, and Langley Research Center was opened in 1917. So we've got over 100 years of working in aeronautics. And then as the NACA grew, we expanded to Lewis Field, which is now Glenn in Cleveland, and Ames at Moffett Field, California, and several other different locations. And I do want to point out, because we are kind of going through this period of history, that the NACA was pronounced exactly like that. They never said that word altogether, right? Now with NASA, we say NASA, but with NACA, if you want to make sure you're correct, you say NACA. You talk about the NACA 0012 airfoils, or the work that the NACA did for aircraft in World War II. So as NACA progressed in their research, started to get bigger, of course, in the 1950s, we had the age of the space come along, and in 1958, NASA, the National Aeronautics and Space Administration, was created. And so that is how we have continued as NASA, based on our NACA heritage. So why are we still working after 100 and some odd years in aviation? And I think this audience is well aware that aviation is really vital to our nation's economy. So it's an important part of the economic driver for our country. So this is pre-COVID numbers, but we had a $78 billion positive trade balance in aviation. That's the largest positive trade balance of any US manufacturing sector. So it's really an economic engine with $1.8 trillion total of US economic activity. So that translates into jobs, it translates into cargo and freight and goods and services. And it really is some of the backbone for the way our economy works. So it's important to us to keep that engine going. Of course, we had COVID, and we saw that everything kind of came to a stop, and there was some downturn in the aviation industry, but now we're seeing the uptick again. And during the COVID years, NASA was thinking of how do we get back? How do we get back to pre-COVID? How do we go further than we were when we shut down in COVID? So this next video is, I'm going to run it and talk while it runs. So it really speaks to, first, how do people look at aviation and getting into it? And then how can we invent a new era of flight? What are the areas we can push on to really make things go faster, to take advantage of the new technologies that are coming along? And NASA has a wide range of interest in this area, from the subsonic transports we saw through here. This is the advanced air mobility demonstration that was done in Reno, Nevada. We're looking at, and I'll talk in more detail, electrified aircraft propulsion technologies. How can we advance sustainable options for subsonic transport? How do we get to quiet supersonic flight? We're building an X-plane to demonstrate quiet supersonic flight. And we're doing this throughout a NASA community that's across the country at 4 different aeronautics centers. We're doing a lot of outreach to try to bring in young people into our workforce and really sparking that interest in what is the next step. Where do we go from here? So NASA's come to start to focus on what we call 4 transformations for sustainability, for increasing our mobility, and for really enhancing the economic growth, pushing forward the economics as important to the United States. And so those 4 areas are the ultra efficient transport, and we're really here talking about subsonic single aisle transports. We're looking at high speed commercial flight. How can we make that accessible? We're looking at advanced air mobility, which is the area I work in the most. And we're talking about how will all those things work together in a future airspace system. What does that all look like? So let me talk about each of these 4 areas, and I'll start with the first 3, and then I'll talk more about the advanced air mobility. So really the driver here is the carbon reduction challenge. So if aviation continues to grow, there's an estimate that by 2050, 10 billion passengers will fly each year. And if we keep the same fleet that we have with our operational efficiency, that would generate 620 megatons it would require 620 megatons of fuel and generate 2,000 megatons of carbon dioxide. So aviation becomes a real contributor to carbon dioxide problem. So how do we do that same amount of travel but reduce the net CO2 emissions? So that's an opportunity, that's a challenge that the worldwide global aviation market has taken on to look to reducing carbon dioxide emissions. And for the United States to maintain economic competitiveness, we want to be a leader there. So there is a big push for the carbon reduction. So as I said, it's the entire global aviation industry has a goal for net zero carbon emissions by 2050. And that's something big that they're biting off. We see 3 ways or pillars that can get us to that type of a future. NASA has a primary role in aircraft technology that will help us burn less fuel, operate more efficiently, and the propulsion technologies that are more sustainable inside those vehicles. NASA has a primary role in operations and infrastructure. How do we operate these vehicles in a manner that's more efficient? How do we work with the FAA and evolve an infrastructure and an airspace management system that helps us operate these vehicles efficiently? And in the area of sustainable aviation fuel, NASA really has a supporting role in that. Other agencies like the Department of Energy have the lead role for sustainable aviation fuel, but NASA's part in that is to evaluate the impacts of that kind of fuel on an aircraft. Does it work in the propulsion system? What other things do we have to do? What technologies need to be developed in order to have drop-in sustainable aviation fuel? So NASA really has a big role in the sustainable future. And again, the overarching focus on this is the single aisle transport airplane market. And this is because that is the largest number of aircraft currently in service, flying the largest number of miles. And the fleet is aging and it's looking to be replaced. And there are several different aircraft that are being developed looking at that market. So we've got not only the usual competition of Airbus and Boeing, but also China and Russia are also developing aircraft that target that market. There's been extensive European funding for commercial aviation. The Horizon Europe and Clean Aviation programs are in there. And they're really looking ahead, believe that some policy issues in terms of what aircraft are operating cleanly and efficiently will influence what aircraft have a share of the market. So this particular kind of aircraft, the single aisle transport, it's a huge segment. There's a lot of aircraft, and it's very vital to the importance of the aviation economic market. So that's why there's so much emphasis on that. So NASA has formulated what we call our Sustainable Flight National Partnership. And this is an emphasis that got an actual augmentation in the last budget process to develop next generation capability to get us on that path to net zero greenhouse gas emissions. And we're doing that through a variety of means, advancing the engine efficiency and emissions. We're advancing the airframe efficiency and how can we manufacture things faster and lighter weight. We're looking at enabling the sustainable aviation fuels. And the other part is enabling the integrated trajectory optimization. So as we work into that Sustainable National Flight Partnership, so the word partnership is very important there, we have on a path for a sustainable flight demonstrator that will demonstrate some of these integrated airframe focused technologies in flight. And this is bigger than NASA can do by itself. In fact, NASA really shouldn't do this, right? This is technology that needs to transition quickly into industry. And so we need an industry partner to develop and fly an integrated airframe focused technology flight demonstrator. We want to mature the technology so they can be inserted into the next generation single aisle aircraft. So that means it has to go fast, it has to be now. So the benefit there is to validate some of these promising technologies so they make it on to the next generation of single aisle transports. And our approach was to use a unusual funding mechanism called a Funded Space Act Agreement. Some of you are probably familiar with our normal Space Act agreements where basically no money changes hands. We do collaborative work. But this Funded Space Act Agreement is a different type of contractual procurement mechanism. It partners with industry by giving them money to demonstrate this integrated focused technologies. And it basically turns the responsibility over to our industry partner through this funding agreement. We ran risk reduction contracts for about a year, from August 2021 to September 2022. And then we selected Boeing as our partner for that Funded Space Act in January of this year. And our first flight, the first flight is expected in 2028. So with this Funded Space Act, NASA's putting in about $400 million into this demonstrator. But Boeing is coming with a lot of skin in the game, putting in around $350 million of their money to make this happen. So we're really excited about the Sustainable Flight Demonstrator. And you notice it's got a different looking configuration. It's called a transonic truss-braced wing. So the transonic truss-braced wing is just that. It's a transonic aircraft, but instead of a large stiff wing, it's got a slender wing that's braced up by the struts. And that gives it some, gives the wing the structural integrity it needs to be that slender and still be transonic. But whenever you go to a completely different configuration like this, we have to take a step back and make sure the technologies are there, that we understand some of the fundamentals about that configuration. And so there have been studies underway for several years in design analysis and in wind tunnel testing to look at things like the Buffett boundary prediction, the STOL characteristics, We have to look at icing, particularly on the strut joints. There's unique structural joints, as well as an acoustic assessment of this new kind of configuration. So they do expect to receive about 5 to 10% reduction in fuel burn through reduced drag. And every percent a reduction in fuel burn is a percent reduction in carbon dioxide. So this is the configuration that is going forward and is part of the Strategic National Partnership. Now, we're doing things other than the outer mold lines of that vehicle. We are, as I said, we've been looking at 5 to 10% fuel burn from the configuration itself. We also have ongoing work in small core gas turbines, where we expect to pick up 5 to 10% improvement in fuel burn. We are looking at how you can put some electric aircraft propulsion elements into the vehicle to, again, offload the propulsion system, offload some weight, and get a 5% fuel burn and maybe a maintenance benefit. And we have a project dedicated to high rate composite manufacturing, looking to say we've got a lot of these single aisle configurations in aircraft that need to be replaced. How can we do this quickly? How can we manufacture these at a very high rate to get them to replace the fleet with these efficient vehicles? So we have a lot of technology, or a lot of effort going into the subsonic transport area. So overall, NASA Aeronautics is about $930 million. And I would say, at least half of that, and maybe a little more, is going into the subsonic transport technology area. A second area I want to talk about, maybe I won't talk in this great detail, but is the high-speed commercial flight, where, as you may know, we have been limited from flying supersonic over land because we're not allowed to do that because of the sonic boom. So our goal is to generate some key data about the noise of the supersonic aircraft to support the development of en route certification standards. So can we get to the point we can fly supersonic over land? And we have been able to design a vehicle that we say has a sonic thump. So it sounds about like a car door slamming across the street. And with that kind of a noise footprint, we're looking to fly this vehicle and gather community response data, take that to ICAO and see if that standard can be changed in order to allow that market to emerge. So NASA is building an X-plane, the X-59. And if you want to see more about it, you can go to the website or the nasa.gov/X-59. It's being built at Lockheed Martin Skunk Works in Palmdale. And we should complete this build soon. It's in its final stages right now, and we expect to achieve the first flight sometime later this year. So this will be a really exciting first time with a supersonic X-plane in a long time for NASA. In the area of the airspace, you can see if we've got a lot of subsonic vehicles flying around, we're going to have supersonic vehicles added in. We have our commercial space program that is ongoing. We've got starting to look a little crowded in the airspace. And so NASA is working very closely with the FAA in terms of what's the future of aviation look like from the airspace and the operations aspect. So up until very recently, we've had an airspace that was basically radar based on safety and density and human-centered traffic and safety management. So one controller, one aircraft, I have eyes on you, I hand you off to another controller in a different part of the airspace. We see that the airspace is going to evolve into what we call the infocentric NAS, where there's a collaborative environment. There's perhaps some what we call service-oriented architectures. So say there might be local providers of services that control certain areas, say like low altitude airspace. We think that it will rely some on machine learning, on the Internet of Things. And that's on the way to what we're calling Sky for All, which is a highly automated airspace system that's complex, but it's also scalable. It has dynamic adaptation. It will definitely have a digital mesh, rely on some artificial intelligence and the Internet of Things. And of course, all this has to be done with safety first, right? Our airspace system is very safe. We want to maintain that as we go forward, even in this very complex and crowded airspace of the future. So we are looking at what we're calling Sky for All. How do we get to there how do we get there from here? So we have led an effort to gather input from the aerospace community, from the FAA. And again, you can Google NASA Sky for All and see what information has been out there. But we've developed with the FAA a vision of the mid-century, 21st century shared airspace. So it, again, has to be scalable. It has to expand when there are many vehicles entering it. You have to be able to optimize it to maintain those trajectories that are efficient. And we're evolving from that trajectory-based operations to the collaborative and highly automated operations. And it is a revolution in the airspace side of aeronautics. So the Sky for All, the outreach that we've been doing, the data we've been collecting, will inform future NASA research, and then tells us what things need to be developed. And then as we develop them, we are working hand in hand with the FAA in terms of how to transition that to them and how to have it implemented. So Sky for All is really important, especially when we're talking about advanced air mobility. All right, so we'll go into that section now and talk more about the advanced air mobility, or as I sometimes call it, urban air mobility, and what those missions mean, because this is a lot of what's going to put a load on our airspace system. So when NASA talks about advanced air mobility, we're talking about a whole suite and spectrum of operations that are safe, they're sustainable, affordable, and accessible. They bring aviation to places we haven't had it before. But we're talking about local and interregional missions. So 300 miles or less, 19 passengers or less. Likely these vehicles will be some type of non-conventional propulsion, right? They're going to be electric or hybrid electric or hydrogen. They may be doing short hops between small airports. They may be doing cargo delivery. They may be doing service from a vertiport to an airport, or they may be doing what's one of the popular missions to talk about is an air taxi mission in an urban area. And that's really what I call the urban air mobility, is moving people around in an on-demand type service in an urban area. But in another area NASA's identified is also for using these kind of vehicles for wildfire fighting operations. And I'll talk more about that in a minute. So in this movie, we're just kind of giving an idea that for the urban air mobility, that it's the vision to create that mobility within metropolitan areas. And that's where we started off. We started talking about urban air mobility and for passengers and cargo. And then we've expanded that as different use cases have come up. So as NASA's moved forward with looking at the urban air mobility market, saying what can we do, working with partners to make this idea come to fruition? How do we mobilize both the vehicles, the infrastructures, the federal and local regulators, right, that have to all come together to play in this? We really have sort of a chicken and the egg in some ways, right? We need infrastructure to be able to operate the vehicles, but we need vehicles to justify making infrastructure. And so NASA's coming, and doing research in this area to show what it might take And again, working across all of our centers and with many of our different research areas to look at what the challenges would be and how we could address those in the next several years so that this industry can really take off. So you can see a lot of our partners, and I really like the tagline, let's open up the skies. What can we do that is new, it's different, it's a new mission. So the missions that we talk about most often are the cargo missions for cargo transport. They are consumer enterprise goods and services, so that package delivery, that last package to your door type thing that we're seeing some industry start up those types of services. We have the passenger transport, the air taxi, that is mostly what we hear a lot of the news about. And then we have missions that are public good. How can we use these kind of vehicles for disaster relief, for wildfire fighting, for search and rescue? There are studies that show us an estimated air mobility market of 115 billion by 2035. So it's a new market. It's not replacing other markets, but it's a new aviation market. It's about, if you look at those numbers, it's about 8 to 10% of the aviation transport economy, right? That we talked about earlier. So it doesn't overshadow that subsonic transport and the large transports, but it certainly is a market that makes people sit up and pay attention. So one of the new projects that NASA is working in this area is looking at how to use these type of vehicles to help with wildfire detection and mitigation. And we're calling that Advanced Capabilities for Emergency Response Operations. This has to do, we're working with CAL FIRE and with some other firefighting organizations, particularly in California, to do demonstrations. But really what it boils down to is that when they're fighting wildfires, they're using visuals of where the fire line is. And as soon as the smoke gets dense enough, they have to move out, move away. And they're only really then operating with that information about 8 hours a day. So we're saying, what happens if we could operate 24 hours a day with basically eyes in the sky on where that fire line is and keep track of what's going on with that, feed that information back to the controllers, maybe dispatch some of the vehicles that can bring supplies to the site as well. So we're really exploring what's the best use of those vehicles for this kind of application. So now we'll talk some about the Revolutionary Vertical Lift Technology Project, which is, of course, near and dear to my heart, where our goal is to develop and validate the tools, technologies, the concepts to improve future vertical lift vehicles. And we're focused on the urban air mobility mission. So why focus there, right? Well, it's a very hard mission, right? But we're again targeting kind of a notional design of 4 to 6 passengers or 1,200 pounds payload, 70 to 100 mile range, speed range 115 to 140 miles per hour, and having a vertical takeoff and landing. And with that, you can complete most of the urban air taxi missions. But you also gain from looking at that kind of vehicle a good place to jump off to variants, to be able to say add some range and do disaster relief, or add some payload and bring in supplies, do this aerial firefighting mission, look at medical transport. Right? So we're looking at a vehicle that has a mission now, but can also be expanded, could be improved, could be modified to provide a variant for other vehicles. In terms of what NASA is doing and what our Revolutionary Vertical Lift Technology Project is doing, we've really focused on providing tools and design practices, guidance for some of these urban air mobility VTOL vehicles. And when looking at where we think NASA's expertise and the industry's need overlap, we see two areas, noise and safety, as our primary areas for research. So these vehicles are very different looking, right? We've seen, when we see the Vertical Flight Society on the eVTOL page has got 200 plus designs, so 400 now. And they all are different and different looking from our conventional configurations. So I asked our NASA concepts design team to say, can you give me a handful of vehicles, generic, NASA designed outer mold lines, that capture a lot of the features we're seeing out in the industry? Don't make it look like anybody's design. It's not any one company's design, but it's generic enough that we can do some trade studies on things like, you know, a tilting rotor, a tilting wing, a quadcopter versus what we call lift plus cruise, where there's separate lift and cruising propulsion systems. So those are what we call the NASA concept vehicles, and those are what you see in the middle of the page here. There is no intent to build and fly those, right? Those are paper vehicles. We are using them for trade studies. We're using them to give us some generic data that hopefully the eVTOL industry can take and use, and they see some application to their concepts. So what we're doing with those vehicles is, on the noise side, we're looking at those and saying they don't look like a helicopter, right? We're pretty good at predicting helicopter noise, but these things have multi-rotors. They have a lot of wing and wake interactions. There's a lot of broadband noise that's associated with this kind of configuration that's not there in a helicopter. So the first thing that we did and have started is making sure that our acoustic prediction tools are accurate for these type of vehicles. Then we want to know, hey, how do those acoustic impacts, how do those vehicles impact the acoustic footprint around an urban area? And how do people respond to that noise, that human response to noise? So we have work in all of those areas. And on the safety side, we identified 3 particular areas: in electric powertrain reliability, in handling qualities and ride quality, and in crashworthiness and occupant protection. And I'll talk about these a little bit more as we go into this. But as we go through our research process, we gain technical insights, we gain lessons learned, we learn how to do testing of different configurations. And we give that information through NASA publicly available reports, through software that is released. We give that to industry. We give it to standard development organizations, we give it to universities, and we do share it with the FAA. Although truthfully, a lot of NASA work goes to industry and industry takes it to the FAA, but sometimes we work directly with the FAA. We have a very strong partnership in our noise area, for example. So as I said, we talked about these concept vehicles, and they really also help the NASA research team connect our research across disciplines. So when we first started looking at these vehicles, the folks said, I don't know what to do. I don't know where to start. We said, okay, we'll start here. If your vehicle looks like this, like something in the middle of this circle, what does that mean for your discipline? What are the things you want to look at and explore if they look like this? And as soon as we had that visual on the page, we started to get those ideas coming out about what research would be important in in all the areas, such as occupant safety and noise, in our modeling tools. How do we do, and what new types of test stands do we need to do validation testing? So in terms of our noise research, as I said, the first thing we develop and distribute noise prediction tools. We have a software catalog that you can provided you're eligible, can download those tools. And so we want to make sure that they accurately model and predict these types of vehicles. Then we wanted to assess the fleet impact of operating fleet of vehicles around a city. And we used the FAA's Aviation Environment Design Tool for that. And we had to kind of trick it into working for these kind of vehicles. And we published how we tricked it. And we're still doing some updates to that to try to give some guidelines on the best way to run that tool. And then, of course, we want to make sure that our tools are giving you the right answer. So we are obtaining flight and wind tunnel data to characterize noise. You may be familiar with a test we did with Joby Aviation, where we had a NASA team out there measuring noise, and we have been able to publish some of that noise in an AIAA paper, and that's at the link that's given below. And again, as I said, once we have noise and prediction of noise, we also want to know how do humans respond to that. What's the community response? What's the human response to that noise? And so we do psychoacoustic research. We have human test subjects that come in, and we run them through a series of different types of noise and measure their responses. So this next movie shows the acoustic test measurement that we recently did last summer with the Moog Surefly. We did this at Lunken Field near Cincinnati. That aircraft has since moved to Springfield, so we're hoping to do another test with them this summer. We sent a team from NASA Glenn out to measure the Surefly in a hover. We had previously made measurements of just the electric motors on this vehicle. So now we're making measurements with obviously the motors spinning and the rotors turning. And we're hoping then to do a forward flight test next with the vehicle in Springfield. So there's Brenda. I'm sorry you can't hear her, but she is saying that NASA is out there to try to understand what the acoustic signature of these vehicles is, so that we can help determine what the community response will be when they come into the communities. So on the safety side of things, we take a similar approach to how we approach noise, where we have assessment tools and guidelines for modeling these configurations, but we also have unique facilities and laboratories to generate data and assess new concepts, and those feed back to each other. So the data tells us what our modeling tools, how they need to be improved. The modeling tools tell us what new data needs to be acquired. And then we transfer those tools and data to the regulators, to standards development organizations, and to the user community. We've really focused on 3 different areas. Propulsion, and in that we're looking at the reliability of electric motors. We had early on identified that as an area of that needed improvement. We're looking at fault tolerance and electrical system standards. So, I mean, you assume when you plug in your coffee maker into the wall, right, that it will work. And we have to have the same type of power quality standards for these kind of vehicles. So when we plug and play different types of avionics and different systems, that they all work together. We have to have the standards available and developed. In handling and ride qualities, we're looking at that as a safety issue, because the vehicle response and the control system authority, the pilot's ability to control the vehicle is a safety issue. But the response to that also impacts the passenger response to the motion. So we know that for these kind of vehicles, we expect that people will need to be using these fairly routinely. So there has to be a ride that is acceptable to the passengers in terms of, you know, it's doesn't have too much acceleration. It's not too scary. It doesn't give them the jitters. And then in the area of crashworthiness, we are really concentrating on occupant protection and safety after impact. And I'm going to show you the next video is our recent test, which made the cover of Vertiflight this month. But this is a test where we took one of our concept vehicles, and this is the Lift Plus Cruise cabin. So it's 6 passenger. We made a full scale, all composite fuselage. And then we are testing it on our impact gantry. And what we're looking for is what kind of loads do the occupants experience during what we thought was designed to be a severe but survivable crash. It was dropped from about 35 feet. And we do have subfloor in it. We have stroking seats that have crush struts. And we expected this to be somewhat damaged, but survivable for the occupants. And so when it shattered, we were very, very surprised. That did not match our pre-test calculations, and was really rather shocking. I was there for it, and was just, I think my mouth was open. But what we've learned from that is that our modeling was not high enough fidelity. And within 3 months, our modelers have improved the modeling techniques. They now know they have to model the entire dummy, not just as a lump mass. They've improved their modeling of the composites. And I think you'll see at the HS Forum in May, we'll have 2 papers there, one on the actual crash and one that shows the modeling, and you'll see the improvements. We can now match that test data. So how do we now know our code is correct? We will make predictions for another set of conditions. We have 1 more of these fuselage sections, and we will drop it and see if we match. And then we'll know that we have that new way of modeling is correct. All right, so summary here. I hope I'm leaving you with the idea that NASA Aeronautics has a focus on global, sustainable, transformative aviation technologies, all the way from subsonic transports to eVTOL to supersonic technologies. We have a priority on ultra-efficient transports, on high-speed commercial flight, and on future airspace and advanced air mobility. There's research ongoing in many areas with partners and collaborators. And if you would like to follow us or know more about what NASA is doing, or join us as a partner, please contact me, or you can look at any of these websites or social media and hopefully get more information. So I think that is all I have. I'll leave that slide up and see if there are any questions.
All right, excellent. Thank you so much. Yeah, like Susan said, if you have a question, drop it in the chat or use the questions block and we can ask it. As of right now, don't have any questions in the chat, but I'll start off with one. Looking at the urban air mobility, you mentioned, the kind of chicken versus the egg, infrastructure versus vehicles, and how much are simulations being used to model the overall operating environment?
So there are simulations of the ConOps, the entirety of what they're calling the ecosystem, and this simulation, depending on how who's doing it and what model that you're using, would have various different levels of fidelity. NASA's trying to develop a model-based systems engineering model framework that can model the entirety of the system, but of course it's really big, right? It's like model-based systems engineering usually used to develop a vehicle or a house, right? But we're trying to do it for a whole ecosystem. So it's in its infancy for that, but there are different models of the ConOps that look at how does the system interact and how would it respond to the different inputs. There's also several different studies being run. A lot of states are sponsoring studies about how and where to put the electric charging systems. They're doing that sort of in a collaboration with electric cars. So, can you get double duty out of some of these charging stations? So I know the state of Virginia recently had a study done by NEXA. I believe the state of Ohio has had one done. I don't recall if Arizona was on that list, but there's a handful of states that are really pushing forward to bring this technology to their state.
Okay, excellent. All right, so I've got a question here from Scott. It says, have you contacted industry experts on the crashworthiness?
So yes, we had quite a few observers for that test. So in and a lot of interest in how the modeling was done. And so, again, that particular test was a test of our NASA design, right? It was not a real eVTOL system, but it was a composite fuselage designed by and fabricated by a composite, model and fabrication outfit that used best practices. So really is a question of modeling, and now we know where we put different stiffeners and things. Had our model predicted that in the first place, we would have built it differently.
Okay, let's see, next question. I've got one from Bradley here. He says he also tracks the USAF AFWorks Agility Prime effort that is working with Joby and Moog. Is there significant sharing of your research with AFWorks?
Definitely, yes. And we have a sharing agreement with AFWorks. And recently, AFWorks sent a team to each NASA center to talk about work going on there. And we've got several different technology interchanges. We've agreed to share data. So there is a lot of sharing going on. AFWorks is really about get it up, get it flying. And we are more in the range of, I want to understand what it's, what are the details of what it's doing, so that we understand how to make the next one, or we understand how to make the next one better. And so we've got a little bit different kind of focus, but they're complementary, and we're working with them.
Okay, let's see. Got another question from Scott here. Have you considered airbag design on the AAN?
Yes. So we did a lot of helicopter crash work where we've looked at and know the industry has looked at airbags, as well as we've had energy absorbing systems. The main things that we're doing with AAM is that when you look at what's being proposed out there in terms of those pretty lightweight fuselage sections with some of them molded in seats and things like that, is really just to get the information to the industry about technologies that are already out there. And of course, they're very weight sensitive, like all vertical lift vehicles are. And what could they use that would not increase their weight, their complexity, but really help protect the passengers? Now, a lot of the companies will also, say, well, they have a lot of redundancy, so they don't expect to be in those conditions. So we're kind of providing that last level of occupant protection.
Okay, let's see. Next question, I've got one from Angelo here. He's asking, is Danette Allen's group, Intelligent Flight Systems, tracking this market at all, or is there collaboration with those folks?
So yeah, so Danette Allen is she's at Langley, and she works in the area that is in our what kind of housed, I guess, book kept under our aerospace operations projects. So it's not as much in the vehicle system itself. We're bookkeeping that autonomous system, the piece that has to talk to the airspace and communicate over in the airspace system. But yes, and that's definitely tracking this this industry.
Okay, let's see. So I don't see any new questions coming in chat. I guess one more I would ask is kind of going back to the, I know it's not the primary focus, but on the transonic commercial market there, how much wind tunnel testing do you guys do, and like what's the time frame between them? And
so there's a lot of, you know, so NASA has, I think, over 60 different wind tunnels of various sizes. The main ones that the Transonic Aerospace Wing has been tested in has been our, you know, our low-speed, larger scale tunnels and our transonic facilities. So they've done a lot. They've done a lot of different testing on that, and again, trying to find out what the boundaries are for some of the things we take for granted with our current subsonic transports, like the, you know, how do we predict that boundary, stall boundary, and stuff like that? It's different for this aircraft. But there's been at least 7 years worth of testing.
Okay, excellent. Well, it looks like there's no more questions coming in. So if you have any closing remarks before I close it out.
No, I just say thanks for listening. I hope it came through okay. It's always, you always wonder when you're talking into talking to a screen, but I really appreciate the interest and you guys asking me to participate. So thank you.
Yes, well, thank you for coming out and or virtually coming out and speaking with us. It was an excellent presentation. We're just so glad we're able to do this and bring in people from across the industry and just our partners from sister chapters as well. And you sounded great on there, so I think this will be a good video for down the road. And for the VFS members, this video should be posted online. It'll take a few days for the post-processing to be done. But overall, from here out in Arizona, I just want to thank everybody for coming out, and I want to reiterate again, if you ever have questions or want to see what events we have going on, please go to the website, vfsaz.org. So.
All right, have a good evening.
All right.